Cool, so this is looking at the 2 additional revision questions that I gave you for the analysis task tomorrow. You can ignore what's on the screen at the moment. I'm going to try and attempt these completely using Kaz screen, not touching pen or paper at all, apart from maybe some explanation drawing stuff for you. First off the bat, document, menu, actions. Clear our history so it clears our screen. Menu, actions, clear A to Z, so we clear our variables so we don't have any issues. Go back, add some, so clear that out. Okay, so I'm ready to go. So this question is found the shape branch of Euclid's tree can be modeled by a cubic function. So we can see that we're expecting something like that straight off the bat. The coordinates of several points on the branch are 0, 15.8, 10, 14.5, 15, 15.6, and 20, 15. So our branch length is 20 meters, we can see there. So this point here is going to be at the very end. 15 point, that's going to be somewhere here. Our 10 point is somewhere there. And we're given 0, 15.8. So that is our initial part of the branch, the join. And this is a nice little thing. What we saw from today in class, this is our y-intercept. So when we have a polynomial form like this, our y-intercept is always going to be a final constant value at the end. So we can straight away go y equals ax cubed plus bx squared plus cx plus 15.8. We have that straight away. Okay. So that's one less variable we need to have. So for part A, find variables A, B, C, D. Well, we've already got D. So let's find A, B, and C. So first off, we're going to, on our Kaz, as always, we're going to do our define. And I'm going to call this T of X for our tree. Okay. Choosing a letter that makes sense for us, equal to AX 3, and I've already made that mistake where I haven't put the multiplication sign there. Plus B times X 2 plus X plus, and I'm going to do 15 straight away. Okay, so that's our function T of X, 3, done. Okay, we have 3 unknowns, A, B, and C, and we have 3 coordinate points additional to our y-intercept one. So if we have 3 coordinate points and 3 unknowns, we can find a solution. We will use algebra, solve system of equations, solve system of equations. Okay, the number of equations, well, in this case we have 3, and the variables we want to solve for is A, B, Now we're going to put this in the form of our function, put our x value equals, gives our y. So for example, T of 10, which is our x coordinate, is equal to 2.5 our y coordinate. T of 15, our x coordinate, is equal to 15.6 our y coordinate, and T of 20 is equal to 50. And that's what we need. Solve. And there we go. There's our values. Okay, so let's write them down over here just quickly. So A, C. A was negative 0.002867. B is 0.5. Is 0.793333. Okay. Now This question, it doesn't go on, we're not overlaying anything to it, but I'm going to reiterate what I talked about today in class, is that we're going to redefine this not with A, B, and C like up here, but we're going to define it using our actual numbers. That if we're overlaying multiple things on the one graph, we won't run into variable errors where we have an A in this equation, we have an A in another equation. So let's do that quickly. Define T of X is equal to okay, done. We've defined it. Okay, find the coordinates of the point on the branch that is closest to the ground and furthest to the ground. Two ways we can go about this. We can graph it. I'll show you that quickly. Ooh, no. Wait. I want a function relation. There we go. Okay. Is equal to T of X. Let's graph that. Okay. Straight away, there's that stuff that I've talked about in class and other videos. We know our domain in this case. We know it goes from 0 to 20, so let's use that. Okay, we're going to set it 0 x 20. Okay, so there is, we need to zoom and fit. And I'm going to set my y, just to give us a sense of scale. My y min at 0. At 0. At 20. Okay, there we go. There's our branch. Comes out of the tree over here, comes all the way along, goes over. Now there is two things I'm going to actually zoom out just a little bit further so we can see. Okay, there we go. So we want to find the closest to ground. Well, the closest to ground is clearly here, and the furthest to ground is clearly over here, or it could be actually just where it leaves the tree. So we've got to be careful with that. It might be here. That's what you instantly jump to, but it may be higher over here. So menu, trace, analyze graph. Minimum, set our left bound and our right bound. There we go, height of 13.8. That's its lowest point. Okay, coordinate 5.59, 13.8. And if we go menu, analyze graph, our maximum, I'm going to set my bound all the way over here at the left. I want to include where it touches the tree. I'm all the way over here, and it is. Turns out, there it's popped up, 0, 15.8. So that's the furthest point from the. We could have avoided the whole graph. We can use fmin, fmax from the calculus menus. Calculus, function minimum. Okay. T of x. We want to find the x coordinate when that occurs, and we're going to look between 0 and 20. Okay, so we're finding the minimum of this function is going to give us the output of x, and we're going to look between 0 and 20 because we know our range. There it is, 5.598. So you could go t of 5.5998. This is our y coordinate, and we can do the exact same thing. Maximum t of x. Find x between 0 and 20. Okay, and it gives us 0, so we're going to find t at 0, but we know that's our intercept 10.8. So that's that question. Now let's look at let's close out of that, cancel all those. Yep, that's fine. Let's look at the other problem I gave. A section of a path along the river's edge can be modeled by a cubic function for the range x from 0 to 250. Measurements are in meters. Following coordinates of the points on the path: 0, 0, 133, 50, 57, 150, negative 15. Equation of graph. This is going to be exactly the same as this problem. And we know it's 0, 0, and it is a cubic function, so our d value in this case is actually going to be 0. So let's define, and I'm just typing because it's quicker than menu for me on a computer. We're going to define a river x is equal to ax to the 3 plus b x to the 2 times the gain plus c times x. That's my river. Okay, I've already jumped this 0, 0 here. Okay, so I have 3 unknowns. I'm going to have 3 coordinate points. So we're just going to menu solve system of equations. We have 3 unknowns. Comma B, comma C. Okay. And we can put them in where we have river of 100 equals 33, river of 50 equals 57, and river of 150 equals negative 15. Solve, there we go, there's our variables. Like before, I'd highly recommend redefining it using the actual numbers, but just for the sake of this video, I'm not going to do it this time. Okay. So that's our equation, which passes through those points. Now, that's the path. Part B, it says the bank of the river is 5 meters to the north of the center of the path. Find the equation of the cubic function which models this. So let's get the pen out. Okay. So what this is saying is I have my path, which is in red, and then the edge of my river is 5 meters to the north of it. So it runs up there, all the way over. Okay, it sits 5 meters to the north of the path the whole way. So that distance there is 5 meters, there's 5 meters, there. It's always 5 meters. So this might seem hard, but we've given a bunch of coordinates for the path. So say this one here, that's at 50. Okay, we know it's at 50, 57. Well, this point that's directly north of it is just going to be 5 meters further north. So this point here will be 50 instead of 57. It's going to be plus 5. So it'll be 62. So the quick and easy way of doing this, if we come back to our CAS, is press up again, press enter to bring it down. We are going to literally just make these 5 meters further north. So negative 15, that would go up to only negative 10. 57 will go to 62, and 33 is going to go to 38. And there's the values of river. Okay. Gives us our equation. Ooh, but I've made a mistake I've just realized, because I've assumed this has still got a d of d equals 0 when that is not the case. Right there, that is 5 meters higher, so I need to go back, press up, let's get our work, bring that down. I'm going to plus d times x, note plus d, find that. I am going to have to add another one, probably not. Algebra solve systems. Solve R. And we got 4. Solve for A, B, C, D. I'm glad I caught that mistake. So our first one, R of X is equal to, sorry, R of 0 is 5. All the rest will be 8. Let's type the right letters, would help. Okay, there we go. There's our correct values. And it's showing that I probably should have defined that before with actual numbers, because now it says find the largest deviation of the path from the x-axis. So we have to go back to this, as we're going back to our path. So we've done the river bit. We started with path, we've gone river, now we're going back to path just to annoy us. But we can just press up to get our bit, redefine that. So we have our equation R of x, and that's for back for the path. So I'm going to just do this graphically. X, and my range is from 0 to 250 meters, so control 0. $250. Asked me to make a slider for A, B, and C. Doesn't save them. Maybe we have to define it so we can plot it. Normally that works. Yes, river. Oh, I've got this bracket there. Okay, that didn't. Now the bracket has gone. No, something is not working. To bring that, and let's try control enter. A, B, and C. Try this now. Really weird. Okay, define R of X equal to There we go, window fit. X max needs to be 250. And we know it's going to be at least 57 from, so I'm going to set my, let's go negative D, positive, go 100 just to be safe. Okay, there's my graph. There's my graph. Okay, find the largest deviation of the path from the x-axis. That's asking when's it furthest away from the x-axis. Well, there's pretty far away, not so much there, but it happens to be at the actual 250 meter mark. So you can see, looking at this graph, it's deceptive compared to looking at the image in the textbook. Don't be fooled by the textbook. Make sure you plot it and get an actual idea. Any questions, stick them on the video or on the Google Classroom. Thank you and bye.